Welcome back, folks. We are diving into 5.3, which is a continuation of our polygon, specifically triangle congruency section. All right. Today, the ultimate goal, let's start right there. The ultimate goal of this section is to use what we call the side angle side congruency theorem to prove that two triangles are congruent. In this specific video, we are going to focus on the definition of this side angle side congruency theorem, and we're going to just basically use it for identification purposes right now. What does it look like when a triangle is using side angle side, or when two triangles are being congruent by side angle side, excuse me. And then we're going to talk about things like inclusion of an angle and which two sides what are going to actually include an angle. So what is the side angle side congruency theorem? Well, they don't try to reinvent the wheel with a lot of these theorems, if you've probably noticed so far, folks. Side angle side. What we're basically saying is if you can say that one pair of congruent sides followed by the next angle after that side, and then a second pair of congruent sides are congruent in two triangles, then the triangles are congruent, all right? I don't know about you guys, but after the last video we did, we talked about proving that every single corresponding part was congruent. That's a lot. 3 angles, 3 sides, every single time? No thank you. These next 5 theorems we're going to discuss over the next few sections are going to be a huge time saver for us and work a little bit more smarter than harder, right? So let's think about this theorem in general. So where does it come from? Well, what we're basically saying is that if we provide enough information, the rest of it will kind of work itself out, okay? So it says if two sides and the included angle of one triangle. So if two sides, AB and AC, and the included, let's talk about that included worm. Included anything, included side, included angle. Included just simply means in between, all right? In between. So, with that being said, we see that angle in between two smushed sides, right? It's a side sandwich with an angle as the good stuff inside. Side sandwich, angle with the good stuff inside. Let's see how we can see this in actual two triangles being kind of next to each other, I guess, or adjacent triangles. So what do we have so far? It's not saying giving us a choice, all right? It's saying use side angle side. All right, well, what do we know? I know at this point that this side, EF, so I know EF is congruent to, go in the order that works, GD. And I'm going to put a parenthesis for my first side. Okay, well, what else do I notice here? What was the thing I told you in our last video? I said we have 2 major look-fors for proving that triangles are congruent. Number 1 look-for is look for shared sides. Boom, shared sides. Reflexive property. So I can say that DF is congruent to FD. So there is another side that we are dealing with. And actually, you put this a little bit lower. I want to put the angle in between. So DF is congruent to FD. So there's our other side. So then the question is, what is the other piece of information? And I'm going to change colors here to kind of show what the other piece would be needing. Well, if I'm doing side angle side, let's just count it off. Side, EF, side. What's the very next angle? Angle, where's the very next side? Okay, so I know that I'm going to have that angle EFD is going to have to be congruent to, we'll do it in the other triangle. Side, what's the very next angle? Angle, and boom, side again. So I need to know that's going to end up being congruent to GDF. And that would be our necessary piece of information. Let's do a couple more practice things on our angles of angles and sides of our side angle side piece of the puzzle. So in our example down here, it says in triangle PEN, name the angle that is included. So we want to identify the angle that is in between, right? In between the two given sides. So it says between P and E, or PE and EN. So the first question, or the first way to kind of identify this is, well, just kind of think common sense. Which vertex is shared between these two segments? Or when we're talking about segments, which two endpoints are shared? Well, obviously they both have E in its segment, so angle E would be it. Don't believe me where I got that from? Let's draw a triangle. What if I draw a triangle PEN? Here's PE. Here we have N. What angle is in between? Angle E. And then it says what angle is in between NP and PE. Well, included, again, which one do they share? They share P. Here's PE, here's NP. So what's the angle that's in between? Right there, P. All right, what about when we want to do an included side? An included side, all right? Or, I'm sorry, which sides are made by this included angle. So it says between which sides is the given angle included. So let's draw another triangle. We'll draw a triangle for hat this time. So H, A, T. And it says between which sides is the given angle included. So where is H? Well, H is right down here. So basically you're asking yourself is what two sides create angle H? Well, we end up seeing that we have AH creating H with TH. So our connection here is AH and TH. Okay? And I've had a lot of questions in the past. Hey, why didn't you put them in a certain order of however you did it? Remember, I'm not comparing two triangles right now, so order doesn't really matter at this point in time. Okay, anyways. So now that we want to know angle T, so angle T is right here. So which two sides create angle T? Well, that would be AT and HT. So AT and H.